Hey, today I'm going to explain what is calculus maximum and minimum on interval. Mainly this is finding what is the critical points, and mainly it's about an equation. For example, this one is f prime of x equals to 3x minus x cubed. Now, for my understanding about critical points is that it's equal to 0 or the derivative doesn't exist. Now, beyond of this, I'm gonna explain how we can make this kind of problems and what is the purpose of it. First of all, let's start. First, we have to derive this equation. We know that it's f prime x equals to 3 minus 3x squared. This is the same equation, only that it's derived. And before it, we know that this is f prime of x. Now, after this, we have to equal it to 0. Why? Because we know that m is equal to 0. And when we do this, equal to 0, I know that this monopolymer is negative. I can pass it to the right, and it's going to be positive. It's going to be 3 equal 3x squared, and this is the same thing, only writing it x squared equals 3, and I can simplify it by 3. This goes, and this is the x is going to be squared, and this is over here is going to be 1. So what I can do with that x squared is the square root. The square goes, and the square root of 1 is positive and negative 1. When I know what is the value of x, it has two values. X is equal to 1 positive, and x is equal to negative 1. After I have those kind of values, they are very important, so I can graph my interval. Now, when I know what is the value of x, I can supply it in the f primes in each equation. Now, I'm going to do this, and it's not so complicated. I know that if I replace it, it's going to be like this. First thing I'm going to do with the positive 1, it's the same, the first value. And it's like this. And it's equal to 3 minus 1. That value is 2. And each time you're going to do this, you have to notice that you have to replace 1 in each matter, or it's going to be wrong. Now, I did it with the first value of x, and now I'm going to do it with the second value. It's going to be the same thing, only that it's going to be negative 1. This is another problem. It's going to be 3 negative 1 minus 1 cubed. This can equal to minus 3 positive 1, and this can be equal to minus 2. Now I have the two values. I have the value of f of minus 1 and the value of s plus 1. Well, now I have the four values. With this, I can graph easily. But the main thing is I want to know what are the critical points, and with that I can find the maximum and the minimum of the interval. Now, when I already know that it can be equal to 0 or it doesn't exist. Now, what I'm gonna do is I'm gonna derive again the same problem. So I'm gonna go that side. I'm going to start the same problem. The derivation of the f it's gonna be f prime of x is equal to 3 minus 3x2. After, well, I haven't derivated yet, so it's still f prime. It's the same problem, only that I'm gonna do it the same again. Now it's f prime of x is equal to, this goes, because we know that this is a simple rule, and it's minus 6x. This goes, we know that that is theorem, and after we have this, we know that this is a critical thing or important thing in these problems, because now I can replace what the x is equal. We know that the first value of x is 1 and the second value is minus 1. Now, what I'm going to do is replace it. First, let's do it with 1. It's minus 6, 1 equal to minus 6. Now, this is obviously the maximum. Finally, we know what is the maximum of this problem. Now I want to find the minimum, and the minimum is the same thing. Minus 1 is 6. We know that 6 is bigger than 0, and that means that this is the minimum. Now, finally we have the maximum and the minimum, and now we have the points that we can graph. So, finally, I already graphed this, but this is the proper way to graph it. I have the x, that's minus 1, and the value that's minus 2. I graph it, it's going to be minus 1, minus 2, and we can see how it curves. Now, the next value is positive 1 and positive 2. After we know that this is the value 1 and 2, the graph, the interval, or the slopes changes immediately. Now, I think that this is a very good problem my professor requested, and I hope that this problem can help you all. If you want to know more details, you can pause it and ask in the section of comments. And finally, thanks for all, and see you next time.